Stars. These hot balls of gas speckle the universe and illuminate our night skies. The star that we affectionately call the Sun makes our planet warm enough for life to exist. And here we are some 3.7 billion years after that first life emerged. But what goes on in the life and times of a star? How are they born? How do they die? What makes a star a star? Let's investigate.
A star is a huge ball of gas supported by thermonuclear reactions that are generating heat and pressure in its very center.
Stars are fueled by nuclear fusion, so they heat up so much and they're so dense in the middle that the atoms within the star get moving so fast they collide into each other and they stick together, forming new, heavier atoms.
This process produces energy, and this energy is what makes the stars shine. Stars are also the major building blocks of our galaxies, including our own Milky Way, and they come in all various sizes, mass, luminosity, and temperature.
So stars are born when large gas clouds start to collapse under the weight of their own gravity. Eventually, this gravitational pull gets to be so intense that the gas, the material, heats up so much that nuclear fusion gets ignited and the star bursts into life.
When a star starts to exhaust its hydrogen fuel, then the temperature is starting to decrease, and so it's going to collapse in some sense. How it collapses depends upon how big it is.
Stars with a lower mass, they evolve as a red giant. This is when they get very big in terms of radius. They then shred all the outer layers and die as a white dwarf.
Meanwhile, more massive stars explode with a bang in a supernova explosion where they spew their guts across the cosmos and seed the next generation of stars.
The sun has a surface temperature of about 5,500 Kelvin, so that actually puts it a little bit on the brighter and hotter side than typical stars. The sun is about 4.5 billion or 4,500 million years old.
Our sun is more or less at the middle of its life, so in another 5 billion years, the sun will become a red giant. This means that its outer layers will expand, engulfing the orbits of our solar system inner planets.
At the very end of its life, it's going to shed a whole bunch of its mass. All the outer layers of the star are going to get blown off, and what's left is just going to be this dense clump of matter at the center, which is what becomes the white dwarf. From then, that is just going to slowly cool off until it's a cold lump of matter.
It's really important to understand several aspects of the sun. Its interior activity, the solar flares, the sunspots. This is because also all this activity influences life on Earth.
You could say that humans have been studying the stars for as long as we could look up and wonder. But our knowledge has expanded immensely over the years with technological advances and scientific discovery. NASA has paved the way for this stellar progress, expanding our understanding of the stars with a variety of missions, studies, and initiatives. When it comes to our own star, NASA's Parker Solar Probe is studying the sun physically closer than any previous spacecraft ever has, flying through the sun's upper atmosphere, a historic first. Another mission is NASA's Sunrise mission, which is a pack of 6 tiny small sats that will launch to study the sun from the Earth's orbit. These are just a few examples of how we study the stars, but of course, as humans have done forever, we could always just look up.